So we're going to touch upon probability. We're going to work specifically in this video with dice. A pair of dice is cast, and the number that appears uppermost is observed. So when we say a pair of dice, we're talking about the standard six-sided die. Okay, so a sample space, usually we call that S. And we're going to list out all of the possible outcomes that you get if you roll a pair of dice. But we're going to do it in such a way that it's very systematic so we don't miss any, okay? And remember, a sample space is a set, so you need the set notation. First die could be a 1, and the second die could be a 1. Sometimes you'll see 1, 1. More frequently, you'll probably just see 1, 1, first die, second die. Then sometimes you'll see a comma, first die, second die, 1, 2. First die is a 1, second die is a 2. And then 1, 3, 1, 4, 1, 5, 1, 6. Sometimes you'll see the commas. More often than not, though, you won't. So you might just see something like this. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And then you just keep the pattern. That was the first die is a 1, and then we have all the options for the second die. And then let's make the first die a 2, and write all the options that we have for the second die, and so on. And there's some really cool things about this. We can visualize every single option. Okay, so we're going to answer some questions. What is the event that the first die is a 5? So first die is a 5. So I'm actually going to scroll down a little bit. I'm going to give you the sample space typed up. That way we can circle it very easily. So if the first die is a 5, remember my notation was like first, second, first, second, first, second. So if the first die is a 5, I'm looking at this right here. And it says, what is the event? We're not talking about probability yet. When you're talking about event, you're just listing the options, listing the outcomes. So the event is the set of those things. 5, 1, or it could be 5, 2, or it could be 5, 3, or 5, 4, or 5, 5, or 5, 6. That's the first die is a 5. Now, what is the event that one die is a 5? Does it say which one? It doesn't. So let's look at that sample space. So again, we're talking about an event. So we're going to use our set braces. One die is a 5. So we just said, if the first die is a 5, that's all of those. But there were two options, right? One die is a 5 could be the first die is 5 or the second. So all of these have the second die as a 5. So if we're looking for that event, we're going to write down all of those cases. So 5, 1, or 5, 2, or 5, 3, or 5, 4, or 5, 5, or 5, 6, or do not duplicate them. So we went all the way across. We did this. Now we're going to go down. 1, 5, 2, 5, 3, 5, 4, 5. We already wrote 5, 5, and 6, 5. Next question. What is the probability that the second die is a 2? So we've changed it. The first two, we wanted the event, which means list the outcomes. Now we want a probability. Remember, probability is a number between 0 and 1. So what is the probability the second die is a 2? So second die is the second number. So second die is a 2, all of these, right? So the probability, the second die is 2, is, it's going to be a fraction, a number between 0 and 1, but I have 1, 2, 3, 4, 5, 6 of those. And out of how many total? Well, if you notice, I had 6 that way, and I have 1, 2, 3, 4, 5, 6. There's 36 total outcomes, so 6 out of 36. You can leave it like that, or if you want to, you can reduce it to 1 out of 6. Either one is appropriate. What is the probability that one die is a 6? So again, part B, we said, part C, what is the event that one die is a 5? Now we're saying, what is the probability? So our answer needs to be a number. So one die is a 6. Again, that can be either die. Here's all the second dies is 6. Here's all the first dies at 6. One die is a 6. Okay, so probability, one die is a 6. My denominator is going to be 36 because there's 36 total. And then we're going to count them. How many have one die as a 6? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice, don't count this guy twice. So that's 11 out of 36. Let's do another one. What is the probability that one die is a 4? Okay, probability 1 die is a 4. So here's the first die is a 4. Here's the second die is a 4. So the denominator is 36. 36 total options. How many have a 4? I've highlighted them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't double count that one. 10, 11. 11 out of 36. So if you look at those, let's actually look at the part E and part F. One die is a 6, one die is a 4. The probabilities are the same. Will that always be true? And go back to when we first asked about events. What is the event that one die is a 5? How many outcomes did we list here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is it 11 every time? I think so. Let's check. What's going to happen, I'm going to go ahead and draw it on this one, is if you're saying one die is a 4, you can see I've highlighted it in blue. But if one die is a 1, it's going to be those. If one die is a 2, it's going to be those. If one die is a 3, it's going to be those. One die is a 4, I've already highlighted. If one die is a 5, it's going to be those. And we already see one die is a 6 above. So it kind of makes this plus sign. So it's going to be 11 every time. Because the first die is whatever number you're looking at, has 6 choices. The second die would also have 6 choices, but one of the choices is the same. So you'd have 12 normally, but you're counting this one twice, so you'd have 11. So what is the probability that only one die is a 4? So that means you're really saying, but not both? So the probability of only one die equal 4. The denominator is always 36. So which ones have one die that's a 4? These have one die that's a 4. These have one die that's a 4. But it says only one die. Because there is one choice right here that has both dies as a 4. So we're actually going to have to be very careful. One die is a 4 would be these pieces. And we count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get 10 out of 36. What is the probability the sum is 9? Okay, well, how do you find sums? Sum is 9. Let's start adding up numbers. Well, how many things add up to 9? Well, I know like 1 and 8, but there's no dice that has an uppermost number of 8. 2 and 7, again, no 7s. What about 3 and 6? 3 and 6, let's highlight that. 3 plus 6 is 9. But what if I wrote 6 plus 3? Does that work too? Are there any other values that if I add them, I get 9? What about 4 and 5? 4 plus 5 and 5 plus 4. Okay, so the probability that the sum is 9, the denominator is always 36, will be 1, 2, 3, 4 out of 36. And you can reduce it if you want to. So let's talk about the sums for just a moment before we move on. This set right here has a sum of 2. This has a sum of 3. This one, sum is 4. That's 5. This sum here is 6. This sum is 7. This sum is 8. This sum is 9. This sum is 10. This sum is 11. And this sum is 12. They're always going to be like that. They're going to be in a diagonal. So here you go. Here's another way of looking at it. Okay? A little bit neater than me circling it. Hopefully you see how this works. Let's try some more. What is the probability the sum is 9 and one die is a 4? So let's translate this from English into math. Probability the sum is 9 and is our intersection symbol. One die is a 4. These have a sum of 9 here. And one die is a 4, all of these and all of these. So what's in common? This one and this one. It says and, it has to satisfy both. So 5, 4 and 4, 5. This bottom is 36, so there's 2 out of 36. Now what is the probability the sum is 9 or one die is a 4? So it looks very similar to what we have above. Probability the sum is 9 or uses the union. One die is a 4. We're going to look at the same thing. Here's all the ones that have a sum of 9. One die is a 4, or these. It says or, so we're going to union them. We're going to circle all of them. All of these and all of these. If it's written down in either place, we're going to write it down. So this is going to be 36 is our denominator, and then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for the yellow plus, 12, 13. 13 out of 36. What is the probability the sum is 5 and one die is a 5? And means intersection. One die is a 5. All of these. Sum equals 5 is this one, this one, this one, and this one. What do they have in common? Nothing. So the probability is 0. What is the probability the sum is 5 or one die is a 5? So I changed it from an and to an or. So or means union. So same picture. Sum is 5. 1, 4, 2, 3, 3, 2, 4, like this. This is the sum is 5. One die is a 5. All of these. Your denominator is 36. But it says or, so I'm going to write down all the things that are circled. So there's 11 that are green, 12, 13, 14, 15. 15 out of 36. And you can reduce that, but I'll leave it like that. What is the probability the sum is even or one die is a 6? Probability sum is even or means union. One die is a 6. So the sum is even. Well, that's going to be 2, 4, 6, 8, 10, and 12. So 2, 4, 6, 8, 10, and 12. Those are the ones with even sums. It says or one die is a 6. So here's the ones that have one die as a 6. So because it says or, we're going to count anything that we've chosen. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 for the green ones. And then we have 19, 20, 21, 22, 23, 24. So that'll be 24 out of 36. Okay, what is the probability that only one die is odd? Okay, my denominator is 36. So odd, we know our odd numbers are 1, 3, 5, 7, 9, 11. We only go 1, 3, 5. So only one of them is odd. That means not both. So which ones have an odd die? Okay, so let's just look at this one right here first. We know that there's a 1 for the second die. Okay, so it can't both be odd though. So we can't use 1, 1 because they're both odd. We can use 2, 1. Can't use 3, 1. We could use 4, 1 and 6, 1. Okay. So that only one I is odd. Let's go again. We can go 1, 2. 2, 2 doesn't have any that are odd. 3, 2 and 5, 2. Then we go 2, 3, 4, 3, 6, 3, 1, 4, 3, 4, 5, 4, 2, 5, 4, 5, 6, 5, 1, 6, 3, 6, 5, 6. Does that make sense? So it says only one die is odd. That means one die is odd, but not both. Okay, so let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And the cool thing about dice, the reason I like to do problems with dice, is you can see every single element in the sample space. So you can draw it out and you can actually circle them and touch them and play with them. And it's really easy to see what's included and what's not.